All right, I'm going to get started, and hopefully Kathleen will join us. So just a reminder that today's meeting is recorded. And also a reminder of the note well. This is the guidelines for participation. Please be aware of what is in the various references that are here. I'm not going to go through them. Reminder of the code of conduct. Just be respectful and courteous. Keep your discussions impersonal. Remember that we're working together for the betterment of the internet, and be prepared to contribute to the ongoing work of the group. Oh, thanks for the volunteers for notes. And we also would like someone to kind of observe the chat session. And if somebody isn't in Meet Echo, if someone can't contribute because they don't have a microphone or can't join the video, just try to echo there. Watch for things and speak up. Yeah.
I'll watch the chat, Ned.
Oh, okay, great.
Thank you.
Thanks, Kathleen.
Of course.
Reminder of where the materials are located. But they should all be here as well. And so let's do the agenda bash. We have essentially talk by June and Yogesh, 5 minutes from Michael, 15 minutes from Paul and Thomas, another 15 minutes from Mohammed, and then some open mic time. Is there any changes we want to make to that? Hank?
Hi, this is Hank. I'm audible?
Yep.
Perfect. Yeah, I think that the multi-verifier presentation might be a little bit squeezed into 15 minutes. I'm not entirely sure. So I want to this is not necessarily a sequence bash, but is it okay if multi-verifier takes maybe 5 minutes longer than we intended it to have?
Should be fine. We still give us 30 minutes of open mic. So we'll try not to cut you off at 15 if we're still going.
Okay, thank you.
Anything else? Mohammed?
Yeah, Osama here. So I just want to confirm I asked for some open mic question. I embedded my questions within the slide. So
okay.
Like, would 10 minutes extra be fine for it, or should I really keep it within 15 minutes?
Yeah, that's fine. We'll just kind of flow into open mic time.
Okay, right. Thank you very much.
Yeah. Okay. Anything else? Okay, that's it. So let's go to the first presentation. And I don't know who's actually speaking.
June should be presenting this. June, are you there?
June may be trying to rejoin. Why don't you start it, and then when June joins, you guys can hand off.
Okay.
Does that work? Or
yeah, it should work. But I'm just wondering, he still sees online. So
I was
June,
just yeah, June, speak up if you can.
Okay, let's not kind of. I think he might be struggling. I don't know, but let's continue. Yeah. Okay. So this is a collaborative work between many participants. Yes, on the first slide. So it's been collaborated with, as you can see, there are many people from ARM, Huawei, Linaro, Fraunhofer, and Ubitech. It's a collaborative work which deals with how when we have situations where multiple verifiers needs to work in tandem. So that's what we are trying to kind of explain here. So please, next slide, please. Yeah. So often we have now how the industry for remote attestation is progressing. We have realized that attesters, as we go along, is getting more and more complex. What we mean by complex is it's like an effectively a combination of multiple component attesters, and there can be many examples of that, but just for example we can say that there can be an attester which is a combination of a CPU and a GPU. Of course there is many more, but yeah, so the point here is that attesters are getting complex, and one verifier, simply a one box which says may not possess all the diverse set of reference values and endorsements which are essentially the preconditions or inputs before we can do the appraisal of such an attester. So when we are faced with this problem where such kind of a complex evidence is coming, which is a combination of evidence coming from multiple root of trust or multiple attester components, how do we apprise such kind of a complex thing? So we decided to work together and come up with a proposal of how different verifiers can come together in a coordinated manner to um, and they can interwork to solve the problem which I just highlighted. So we prepared a draft, and the draft is right there in the link. I would request everyone here to have a read and provide us a feedback later after the call or in coming days and weeks. If anyone has any questions, feel free to interrupt us in the middle. Yeah. Okay. Please, next slide, please. Yeah. So we started with the hierarchical model of um, this is a topological pattern where the attester is sending a composite evidence to the lead verifier. The lead verifier has knowledge about the individual subcomponents and how it should break down the individual sub attester evidence and route it to different verifiers. And lead verifier is potentially dispatching the evidences to the individual verifiers and collecting the individual attestation results coming from the each of these verifiers, and then collating it as a combined attestation result, which we are calling here as an aggregated attestation result, and putting its signature behind it, and it's sending to the attester or relying party. So based on the deployment model, whether it is a passport model, the attester would be talking to a lead verifier, but if it's a background check model, it's potentially the relying party which talks to the lead verifier. And each of these sub evidence is signed by the corresponding attesting environment. So potentially there could be an outer signature on the combined evidence. Yeah, so that is the one topological model we have we envisage that this is how there could be a potential deployment where multiple verifiers work in tandem, potentially the lead driving the interface to the attester relying party, and then it's in the background it's communicating with different verifiers, collating attestation results, and then shipping the attestation result to the attester. So that's one model which is known as hierarchical model. Yeah, Hannes, you have a question?
Yeah, I was wondering, why does the lead verifier need to aggregate all the result? Why is it not just basically act as a front end to the relying party? So the relying party doesn't need to understand the complex structure behind its just.
So it really depends. I think your question is more like an implementation specific. How much of the lead verifier should pass in the aggregated attestation results? Like we have EAR, so potentially it can filter the different submods of AR1, AR2, ARN, and pass an either much richer information or much lower tired down information about the individual attestation results. That's really up to the policy of the lead verifier of implementation, I believe. So
Well, it depends. Like if the draft proposes that there would be a new aggregated attestation result format rather than the existing sort of more simplistic aggregation result, then if that is the case, then I'm wondering, does the relying party really need to understand all the details about the structure?
are you talking about the structure, or are you talking about the trust aspect here? Because trust is certainly what the attester or relying party has to know about it.
Maybe
Because
not.
yeah.
Maybe not, because if the yeah. So
Yeah.
so I think that's the key question for me in this diagram. Like, why does it need to know? Because it creates more complexity.
So I don't necessarily say that it. I would see it as incomplete model if the kind of way you are suggesting, because the one reason is potentially the attester can be reporting evidence from multiple root of trusts, and if it doesn't get results about each one of the root of trust, everything, then it's a partial attestation result, not a complete attestation result. Yeah, sorry, Hank, you have your hand up.
Yeah, I think this to Hannes's question. I think that's all really depends on how the attester is produced, then put into the field, how many of them are there, and how are they managed. So this is of the very simple answer. So you were going to complexity, and this is already reducing complexity by making it hierarchical. So first of all, otherwise, if you would not do it like this, the attester would have to know which verifier to talk to, all of them, which is complex. That is actually complex. But now we're talking message complexity of what does the relying party actually need to know. And again, as Jorgos said, that can be underwhelmingly complex with a yes or no Boolean result. That is typically not the case. Typically you want to do something else. For example, like you went through a hierarchy model, just FYI. If that's not good enough for you, come back to me for more or something like that. So the complexity actually is really dependent, as Jorgos said, on the lead verifier's policy, and you can boil it down to a yes, as always.
Annette, you are.
Yeah, so maybe you'll get to it, but it wasn't clear to me whether the partitioning of the verifier was to specialize in a different aspect or phase of the verification, or whether this was intended to do that there are redundant verifiers that are doing,
No, the verifiers are mostly based on its capabilities. We are not we are not saying that this is kind of a load balancing activity where, okay, I will pick 2 out of 4 because, or 4 out of this set because there's too much. No, it's not load balancing. It's based on the capabilities.
Okay.
So I have a question here, Yogesh.
Sure. Yeah.
Is this a lead verifier just acting as a mediator? Talking to the other verifiers and aggregating the results and signing and sending back, or does it also verify something? And does it have any rules that it will basically say yes or no, depending upon which verifier say what, and what's the thing here?
That's a very good question. Actually, that's again depends on a particular kind of use case. So in terms of the trust, if the lead verifier may have some kind of a signature verification for the complete token, then that is one job it can do. Then it has to have the knowledge about the individual, from where what is the composition, so that I can route the evidences to the individual verifiers. So it needs to know the capability of each of these verifiers. So there's a lot of things which it needs to be aware of. It is not just like a simple blind actor to just forward things blindly. Yeah, I know it's a complex subject. I think maybe I'm happy to kind of go in the more detail in open mic, because I just conscious, yeah, but up to the chairs.
Yeah, we're at 7:15. That you've used up 10 minutes. So
Yeah, okay. So
you
yeah,
have more slides.
yeah, I have a lot of slides, not more, but not a lot, but yeah, we have slides. So let's continue. So another model is a cascade model, where I think this has been very much as well prevalent in the industry as we speak. So the attester sends the composite evidence to a verifier. The verifier has only a partial knowledge about what to verify from that. So it just verifies what it understands and then constructs a partial attestation results and forwards the evidence downstream, the composite evidence down the stream to another verifier, which then um, decodes whatever it understands and continues the process until the entire verification is done. And in the return path, the aggregated attestation results, once everything is been evaluated, the aggregated attestation results are returned back to the source from where the partial attestation results were received from, and the chain completes when all the attestation, there is result to each of these individual sub-attesters. And then you would construct an aggregated attestation results and send to the attester or relying party. So yeah, this is known as cascade model. Yeah, it's also explained very well in the draft, so please read it. Yeah. Okay, next slide. And obviously this is the slide which explains that not necessarily you have to be fixated on these two combinations. You could have potentially a hybrid model where, as you can see in this picture, the verifier 2 acts as a lead attester, and the lead attest verifier 1 and verifier 2 are in the cascade model, but the verifier 2 acts as a lead attester to root the does the partial evaluation of the combination, and then takes help from verifier 4, 5, and 6 and get the results to verifier 2. So any combination is possible, whether you want to do the cascade first or you can do the lead first followed by the cascade. It's possible. Yeah. So next slide, please. Yeah. So I just wanted to highlight before I go into the real world use cases that this is not an exhaustive list of use cases, because when we tried to figure it out where these topological patterns are applicable, and we found that maybe there are 10-15 use cases and we cannot prepare 10 or 15 slides. So these are certain key use cases, by no means exhaustive. And so these are just few examples, and there may be more. So this one is from the confidential containers project, where this is an example of a layered attester, effectively, where you have a workload running in a confidential environment on top of a root of trust, which is from a TEE like Intel TDX, or uh, maybe SGX as well, or SEV-SNP or ARM CCA. So the composite evidence is essentially a combination of a workload uh, token and a platform token in combination, and layered, potentially have some crypto binding between the two. And so it is sent to the key broker service, which is the relying party, which which would receive that evidence. It needs to know that whether the application which needs to be decoded is running in a TEE in the right set of security properties before it can release the key. So it just forwards the composite attestation to a COCO AS workload verifier. But first, the workload verifier sends the composite evidence to Verizon, which acts here as a platform verifier. So Verizon does the platform verification for the root of trust, the TDX or CCA. In this case, it is CCA. So you would verify the platform bit, and then identify the realm identity or the workload identity, and stash an aggregated attestation results with the realm claims or the workload claims to the COCO attestation service. The COCO attestation service verifies the workload claims, and the composite attestation results or the aggregated attestation results are sent to the relying party, which assesses the trustworthiness of the entire chain and makes a decision to release a key in the confidential container to let it decrypt the workload and run the workload. Yeah. Muhammad, Usama, you have a question?
Yes, I would like to understand what are the security and privacy benefits of this design. Because my first understanding from your slides was that probably you are going to kind of limit the evidence and send only the evidence of, let me take the example of CPU and GPU. My understanding was that you will send the CPU evidence to the CPU verifier, and you will send the GPU evidence to the GPU verifier. And in that sense, I see a lot of value in that. You at least cover the privacy concerns, but the design that you show here doesn't do that. So it sends the composite evidence to both verifiers. So what's the benefit of doing this?
So I think this is the model of key broker service. Your question about the CPU and GPU is on the next slide, so I will answer that. Here, the model is that it's a layered attester, which is where it's essentially a layering of evidence, and essentially you could split it the way you want, but what we are trying to highlight here is that there is a realm verifier, there is a workload verifier and a platform verifier. These two are distinct roles done by distinct verifier. How you organize it is very much up to the deployment scenario of the project, and this is the project which actually is using this kind of split verification. That's what this slide is highlighting.
Right, but is there any privacy or security benefit in separating the two verifiers?
Yeah,
What's your
because
motivation for this?
okay, because let me give you an example. The workloads may be in charge, in control of a relying party. So the workload verifier may be a part of the relying party, which can be a library within the relying party. And the platform verification is not something very relying party cares. So it sends the composite evidence to the platform verifier, which then verifies the platform bit and then returns an attestation result which has workload identified, and then it is the relying party's job to do the workload verification. So these are different activities and different roles. So
So now I'm even more confused. You in the
why?
beginning you said it's a layered attester in the beginning when
Correct.
you were explaining the
Yes.
slide, and now you
Yes.
say it's a composite attester which is sending over the
So
composite.
composite attester is a term we have defined in the draft. Composite attester could be a layered attester or a composite device, which are the two things it can be. So when I say composite attester is composite attesters, one flavor is layered attester, which is being shown here actually. Does that
They are
help?
two different things. I don't think they are the same. So according to 9334, RFC
Mhm.
9334, they are two different things.
Yes,
I
but
think you are mixing the two. Layered attester is when you have the layering between the two, and composite
yes,
is when you have, let's say, a CPU or a GPU. So I don't see whether this is really layered or composite, but
this is a layered
I
attester.
will give others the
The-
chance to speak.
As I mentioned, this is a layered attester. Yeah, Hank, you want to go clarify more?
There are so many things now open that I'm not entirely sure what to answer. So first of all, that the document says standards track is obviously a red herring. That should be at the moment, I think, a informational document. So there's that. Coming back to messages, yes, message design will be impacted, and probably there are we need group protocols like for DAA to kind of orchestrate that. Maybe it's gonna all be mud, and with enough mud URLs and mud files, you can also solve the problem. So these are architectural patterns we are designing here for, and we show the use cases they're originating from, to then decide which is the minimal incision we have to do here to create, if necessary, new protocols, but most certainly design constraints on each or composition constraints on each or other messages that we have under control over here, right? So you can't really control a TPM evidence, for example. So so that is, I think, answering most of the questions here. I'm performance-wise, yeah, sorry, R4Z is in the data tracker.
Yeah.
Kathleen?
So I see the fit for this, but in recognizing the questions in the chat, I will read the draft. You know, I could see why you might want to verify to one complex policy within a defined code set, which you're referring to as a verifier, right? And it's not necessarily completely separate, but it could be that you have a few verifiers, but each specific to a policy set. So
Absolutely.
I can see the correlation. I'll read the draft and then provide some comments.
Great. Thank you so much. Yeah. Shall we move on? Or Hank?
Just a quick idea about the privacy and benefits were here. Yes, of course. If the lead attester, so the lead verifier might be under your local domain control, which is an architectural setup decision, then you could expose only subsets of the evidence or dispatch evidence only to parties that really need it. There are other ways to conceal evidence in a bigger message, which is worked on in other working groups today. But that is something I think that we talk about there.
Sorry, you are breaking. Shall we move on?
Can you type your question in chat, Hank? And we'll come back to it.
So Usama, this is the slide which you were.
Oh,
yeah,
yeah,
you were
sorry.
breaking. We couldn't understand what you said. So So Usama, this is the composite device use case which you are referring to, which is here there are two distinct verifiers, Intel Trust Authority and NVIDIA Remote Attestation Service at the top, and the model owner, which is the person, which is the algorithm definer, and the data owner, which defines the data for the algorithms, wants to deploy those two things in the confidential computing environment. And so the composite device reports composite evidence, which is a CPU and GPU combined evidence. And so individual verifiers verify those, and a result is an aggregated attestation result given to the relying party from the attester itself. And then the relying party makes the decision and then provide the keys to decrypt the model and the data required to do the model inferencing on the server. So this is, and then there is a confidential mesh computing as well, which is similar stuff. Yes, Usama.
Yeah, just to understand this diagram, so what you are saying here is that the evidence going from the Intel Trust Authority to the NVIDIA is basically the same as which was going from the TEE to the Intel Trust Authority. Is this correct?
No. In the one of the options which is there in the documentation is you have a combined packet of TDX and GPU attestation as a composite evidence going to the Intel Trust Authority, and then Intel Trust Authority delegates part of that evidence to the NVIDIA remote attestation, which is belonging to the NVIDIA root of trust. Intel Trust Authority only verifies the Intel root of trust remote attestation. Just to be clear, yeah.
Right. Okay. So now I see some benefit that NVIDIA never gets to see the evidence that was intended for Intel. Right.
Correct.
So
Absolutely right.
that's good. So the second thing that I would like to understand is there any possibility in the hierarchy that the Intel Trust Authority also does not get to see the evidence which was intended for NVIDIA? It's the other way around. Why should I send that evidence to Intel? Intel sees both. The other thing is good. NVIDIA sees only the one it is intended for. Why does Intel see both? It doesn't have to, right?
So Intel Trust Authority acts as a lead verifier, and they are working in tandem. You understand that these are different roles, but internally they are working together. Hannes, you have some more things to add?
Is there a change in the architectural assumptions that vendors are not going to share their reference values and other information, and that we now need to route all the evidence to all the respective manufacturers? Is that sort of like, I didn't understood it previously. Previously, I thought the model was you have a verifier, you can run it, and you basically import or enter the necessary information, reference values or endorsements from obtained by the different manufacturers. But now it's kind of sounds differently based on that slide.
Sorry, what is different here, Hannes, which we haven't?
The difference here is that Intel in that case doesn't have access to the reference values and the endorsements from NVIDIA.
Correct.
That's why you
Absolutely.
need to relay. Is that now the model? Because that wasn't the model previously, in my understanding.
No, it is not the Intel Trust Authority's job to verify NVIDIA's attestation, right?
Why not? Because
No,
it just needs reference values. NVIDIA just needs to publish reference values and endorsements about the hardware it has.
No, but there could be different policies applied on that. I think we are rat holing on this. These are two separate blocks, so it's different verifiers. You can't put everything in somebody else's vendor's shoes, right?
Well, they could publish it like they did it with FIDO.
Well, I because there could be different policies and different things. Okay, you can do it. What you're saying, folding the two roles together, so that one deployment can do that. But this is just the roles, and we are splitting the roles here. We have to be careful in saying that what you just said.
Okay, I never read it that way in the RATS architecture. That this is the model you are trying to.
So we have a deep queue. 2 more slides, and we're 5 minutes over. How do you want to handle it?
Yeah, I'm happy to answer.
Do you want to finish? Do you want to
Yeah.
Okay,
do
let's
QA the
finish.
rest of the time, or do you want to finish the slides? 'Cause we're not
I
gonna
think
get
let's
through all of
finish
it.
the slide. Yeah, let's finish
Okay.
the slide. So there is another one which is from Thanasis. So if he's on the call, please explain this use case, Thanasis.
Yes, I will do it very briefly because I understand we are over time. So this is again another example of the hierarchical model, and it actually shows an example of what is the discussion about till now regarding the privacy here, right? So this is in the context of the UDI architecture reference framework. What they have been currently doing is that they have like in the middle the wallet, which is basically acts as the holder, and it gets issued a lot of attestation attributes. There is, of course, some type of a gap between what the UDI and the ATAS is defining like as attestation attributes, and there is like an ongoing discussion of how to bring this closer to the RATS definitions of the verifier and the attestation. But the whole point, what you can see, is that you are having all of these issuers that are issuing reference values to the wallet, which can be able to act as the composite attester, and this is what then will be sending to a relying party, to a leading verifier, that will be able to select what is the appropriate verifier from a trusted list of verifiers. So I want to highlight here a couple of points to the questions that have been asked. This is an example also when it comes to privacy. So trusted verifiers, they can belong to different domains, even like in different countries. So whenever you are issuing a list of attribute attestation, they need and they can be verified by the different verifier as part of the trusted list of verifiers, which can be selected by the relying party based also on a policy. In this case, to also Hannah's question, for instance, you should not be able to actually publish the reference values outside of your domain. So this is actually a need in this case to be able to have this type of composite evidence. And the interesting point there is to actually bridge the gap between definitions of the UDI and the RATS model. And the whole point is that they want to have actually also proof of wallet integrity and additional attribute attestations.
Okay, thank you. So I think I would conclude. If you go to the next slide, I think you will see a lot of simple things, comments, questions. We are happy to discuss it off on the open mic, or I would request everyone to please read the draft, send their comments, and so that we can have a healthy interaction in our next IETF session. Thank you so much.
Okay, thank you. We're going to go to the next presentation now. Which is no slides. Michael Richardson, you have 5 minutes. Unless you didn't have anything to say. Okay. Unless we hear from Michael, we're going to go to the next one, which is CoServe. So.
Thank you, Ned. How is my audio?
Sounds good.
Okay, cool. So I'm co-authoring this draft with Thomas. I'll go through some introductory slides here and then hand over to Thomas to dive into some of the details. So if we can go to the next slide, please, Ned. Thank you. So let me just assert the relevance of this to the group and set the context. So this is about the conveyance of endorsements and reference values to the verifier and is part of RATS architecture, so is within scope of RFC 9334. And it's not just a theoretical part of the RATS model, it's shown to be a real industry requirement as well. There are services available today, with examples being the NVIDIA RIM service, AMD's key distribution service. They're solving somewhat different problems, but still within this general conveyance category. And that's just an illustrative set, not an exhaustive one. They do exhibit some fragmentation today. So the APIs are proprietary and data formats certainly disjoint, if not necessarily proprietary. You could argue that today's level of fragmentation is manageable, but the risk is that it gets worse. So endorsement providers and consumers become more numerous as the general attestation footprint grows, and then either with confidential computing or other use cases. This makes life hard for verifiers in particular, because it's the verifiers that need to pull these data from across that supply chain. So the question we're left with is, what more can we do in RATs to offer more guidance to the industry so that we can hope for a future where there is better alignment, more standards, and more common tooling? So that's the problem statement. Can we move to the next slide, please? So why CoServe? In trying to answer the question from the previous slide, there are various things we could do, right? We have these reference interaction models that we could enhance, which are currently focused on evidence conveyance, more on endorsement, less than on endorsement conveyance. And we could go further still. We could make things more concrete, actually have things like open API specs rather than just interaction models. And I've been having some conversations around some of these things with the group. Some of us met at FOSDEM earlier in the year, for example. But what we've landed on is, I guess you could call it a baby step. So regardless of API and interaction model, there has to be some kind of data format to facilitate the transactions, a query response language, if you like, but not just any query response language, a language that is tailored towards the artifacts that RATs defines. So Thomas and I felt that this was a nice, concrete, self-contained activity. We could write a draft for it, and then we could do some prototyping around that draft to learn more. So we decided to press ahead with that. So that's why we have CoServe, which is the concise selector for endorsements and reference values. And I'm going to go over a few guiding principles that we followed in designing this before I hand over. So if I could have the next slide, please. Thank you. So we wanted to decouple the message from the transport, first of all, and create something that could transact using different transports or interaction models like HTTP or CoAP. We wanted something that could be used either as a simple sort of get me everything method, but could also handle things like deltas or pub/sub sorts of models. Using the transport efficiently, so something that suits either client-side or server-side caching, for example. And we wanted to support verifier code that's running on constrained nodes, hence optimize the data volume and minimize the client-side processing burden. And then over the page, if you'd have the next slide, please. Thank you. So we did want to specialize this for RATs and not have it be too arbitrary or general purpose. We want it to be general purpose enough, but still being focused on the conveyance of endorsed values, reference values, and trust anchors. And of course, to use the existing RATs designs where possible. Part of that means aligning to a CDDL data model, which we encounter in many other places. And then finally, to allow distributors to aggregate from multiple sources with flexible trust models. By that flexible trust model, I mean that the consumer could choose to either fully trust that distributor, even if the distributor is giving out, if you like, secondhand or aggregated information from downstream supply chain sources, or we can support a trust but verify model where the distributor is trusted in the first instance, but is also then required to provide auditability for all of its results and provide bundles of data from those primary sources that the consumer could then go and do a deep verification of everything. So that is the scene setting done. I'll now hand over to Thomas, I hope, to go through details of CoServe.
Sure. Next, please. Okay, so this CoServe is the result of our musing and tinkering over these requirements and design principles that Paul has just highlighted. And in a nutshell, this is CoServe is a CBOR map that wraps a query alongside the corresponding result set. And that's essentially a core item that can be exchanged by the actors in this endorsement API business. In concrete, so one concrete way it can be used is that the requester composes the query, CBOR encodes the CoServe object, and then takes the base64 URL of that and put it into the URL of a GET request to the distributor. Then the distributor computes the result set, updates the CoServe with the results, signs the blob, and sends it back to the requester. And while doing that, it also sets the cache control headers of the underlying HTTP or CoAP transaction in a way that is compatible with the lifetime of the results. That may be per local policy or and any other constraints that are set by the upstream supply chain actor. And this way, the query result blob, right through the signature, becomes effectively a web resource because it has a stable URL and can therefore be cached by the web infra. But at the same time is end-to-end secure because of the signing. And cannot be tampered with by any malicious intermediary. So, yeah, that's it. Okay, let's go with the CoServe internals next, please. So, starting with the query part. So basically, queries allow an endorsement requester to describe two things. What kind of artifacts I'm interested in. So are they trust anchors or verification keys or reference values, endorsed values, etc. And this is the artifact type. And also what attesters I am interested in, what we call the environment selector. Next, please. So, okay, so this environment selector is the thing that allows the requester to describe one or more attesters. So it's an array, and that's how we allow multiplicity. The way to describe this is either using their class or instance or group identifiers. And these are straight from the Quorum data model. We take them as is. That's the RATS type system reuse that Paul mentioned before as one of our design principles. Next, please. Okay, so this slide here we use SQL syntax to exemplify what the semantics of the selector is. So basically how the query is mapped internally is really not the CoServe business, but here we are using SQL, but for example in Verizon we use a key vault store, so it's a different thing. But just to be clear, what you should expect from the selector. So in a nutshell, the basic is OR semantics, right? So all the entries in the array are alternatives. But the only exception is when using class, and in that case, the class parameters are taken in end. So these two examples, the first example uses the class selector to query for two kinds of attesters, one identified by the class ID and vendor, and the second with just the class ID. While the second example uses the instance selector to query two specific attester instances, one with ID 80, blah, 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 and the other with ID IZ, etc. Next, please. Okay, so that concluded the survey of the query part of the CoServe, and now we move to the result set, which is a map with an explicit expiration time, this expiry here, that says when the results are going to become stale and therefore they should not be used anymore. And it's decided by the endorsement distribution based on its internal knowledge, upstream feeder constraint, etc. And the result itself. The other thing is, the most important thing is the result itself. It is expressed as a list of the selected artifacts based on the artifact type in the original query. And each artifact is expressed as a quorum triple plus the authority that asserted that specific triple. And we call these quads, as in RDF. Okay, next, please. Yes. So this is an example of a reference value quad. Simply, again, the map with the authority as quorum crypto key type and the ref value triple. And very similar constructs exist for endorsed values and trust anchors. It's very regular. So you've seen this, you've seen all. And the acute observer here will probably notice the fact that there's a potential huge amount of redundancy because the triples probably will share a lot of the authority fields, and because the authority, the crypto key type choice can be quite hefty, up to few Ks in case of a certificate chain. That's a very, very good there's a very good use for Seaborg Pact in this case, and probably Carsten can say more on this. If not, I will switch to the next one. Prototyping, yes. So this back work is carried out in parallel with the prototyping, as I said before, and with one activity informing the other in this circular learning exercise. And we use Verizon as the experimental platform, not just because we know Verizon inside out, but also because it's really quite a natural fit for this. Here, I won't go into the details. There are backup slides if you're curious, or you can get in contact with us directly if you want to know more or even collaborate. We are absolutely open to that. We would be enthused by anyone popping up and showing interest in collaborating on the prototype. But just two things: the fact that there are two Verizon packages that we are dealing with in the context of this prototype. One, the CoServe proper is built on top of the Verizon Quorum package, and we use Quorum implementation massively, and that's so good. And the other thing is that the CoServe API endpoint, which is a simple request response HTTPS thing at this point in time, is implemented as a new front end within the Verizon Services package that connects to the existing Verizon Trusted Services. So a pretty straightforward integration, pretty straightforward architecture. But if you're curious, click on the links and you'll see all the magics. And I think that's it. Thanks for listening. So if there are any questions and there is time, we're happy to take them. Otherwise, feel free to contact us directly, or better, start a thread on the RAS mailing list, and we can take it from there. I'm not sure what the time is, so sorry.
Yeah, you had till 7:50, so you're 2 minutes.
Okay.
You have still 2 minutes for questions. Any questions? If not, we will jump to the next presentation.
Yes, go ahead. It looks like more will be discussed during open mic, just to keep the flow going.
Okay.
Cool.
Osama.
Right. So thank you very much. We proposed this topic for last IETF. Unfortunately, there was no space, but thank you for this opportunity. It's a joint work with Mariam, Thomas, and Hank. And next slide, please. We presented already in the TLS working group in the last IETF. So there are some issues related to RATs, which TLS cannot solve, of course. So that's why we want to just give a brief context and repeat what the problem is. I assume people have already kind of listened to the TLS talk, or at least the people who are interested in discussion have gone through that. So I will be quick in the context and problem and the things that we are repeating, and focusing more really on the things which are really related to the RATs working group and where we need help from the working group or some opinions on that. And then describe some open problems. And in the backup, we have the protocol if that's required to be discussed. So next slide, please. Right, so the context is this draft for SATI TLS attestation, presented a couple of times in TLS working group and a few times also in the RATS working group. In the TLS working group, there was a call for adoption, or let's say that the editors asked for adoption, sorry, not the call for adoption, with a priority on confidential computing. And unlike RATs, so they have a very high standard for the security. So every protocol change which is non-trivial would go through the FAT analysis, which is the formal analysis trials team. And there we have done some formal analysis which we would like to share with the RATs working group. And the summary of that is that it breaks the server authentication property of the TLS. And we have some proposed solutions for that, which is the new draft, as well as some proposals for the intra-handshake attestation as well, which are mostly to be dealt in the TLS working group. So I will not be describing the solutions within the intra-handshake. I will only be describing the one which is the post-handshake. So there are quite a few open problems for both internet drafts, namely the one which is written on the top, number 1, and the one which is pointed out at number 4, for which I'm one of the editors as well. And then finally, I will talk about the terminology hell, which is there. And let's face it, so Mike already talked about it in the last IETF. So I think the thing is that we are creating a lot of terminology which is not consistent, and we really need to see this problem and solve this problem in some way. So what I will do in this talk specifically is a very abstracted view, namely that it is not exhaustive at all. I will really focus on the confidential computing use case, and with a very simplified model where the verifying relying party is defined as the combination of the verifier and the relying party. Next slide, please. And please feel free to have any questions. I think we do have some time for which we can do some discussion. So if there is any clarification question or a discussion question, please feel free. So this is one of the things that was confusing in the presentation I did in Dublin. So somebody asked what is the relay attack, and then there was a discussion on what is relay and what is a replay. Is it relay or replay and so on? So I put in one slide on this, that the problem with remote attestation is that, first of all, from privacy perspective, the claims become visible to the passive adversaries. Namely, it could have some hardware level information, which is now available to all the adversaries, and they can make use of this. And from security perspective, the relay attack is shown in the figure, which is namely that the verifying relying party will send over a nonce. A tester which is malicious will simply forward it or relay it to a genuine trusted execution environment, get an evidence which is believable because it's a genuine trusted execution environment, and then this malicious attester will relay it over back to the relying party. And that's what we feel is the real problem. That is what I have summarized, that the attester is malicious but tricks the verifying relying party to believe that the attester is genuine. So that's the main issue where remote attestation cannot help. It needs some secure channel in order to avoid this kind of relay mechanism, and some kind of encryption via some secure channel with which it can provide privacy. So next slide, please. So among the secure channels, TLS is one of the most common ones, and particularly for confidential computing, other than noise, which is used and recently proposed and used, not to my knowledge, outside of Google. So all other solutions actually use attested TLS. And that's what we have here on the slide, just comparing the two, TLS and remote attestation. The key point is that they are two different trust anchors. On the left, the certification authority, and on the right, the hardware manufacturer. They have two different chains, and one can actually leverage both, and they have very different properties that are really complementary, meaning that the CA is giving you guarantees about who is the owner of this server. And the hardware manufacturer or the remote attestation process is guaranteeing that what is the software which is running inside, what's the software stack, and all these mechanisms related to that. And I try to make an analogy of both in the bottom. So I will just say that that's basically at a very high level. It's on the left side, that is the identity. On the right side, there are claims, and most importantly, the measurements. Next slide, please. So there are a few IAB statements related to remote attestation only, and Hank will probably speak about this if required. So there is a IAB statement, and then there was a CCC response on that, and then they amended the statement, which is linked on the slides. Next slide, please. Okay, so basically, remote attestation only is one of the sections in the proposal. In the Internet Draft section 6.1, what it says is that do just remote attestation and not authentication. And that's where we see that is shown in the figure, that the TLS client from the TLS perspective and verifying relying party from remote attestation or RAT's perspective. And on the right side, the TLS server and the attester from attestation perspective. And what we have here is that it sends over an evidence which says what is the measurement, what is the key, and that signs by the attestation key. So a user wanted to connect to cloud.example.com, and the question is whether an average cloud customer would be happy if he is just given an evidence and not an authentication that he's really connecting to that cloud.example.com. Next slide, please. And what can happen actually is that now if we don't have any PKI certificate, what can happen is we don't have any identity authentication at all, and it can go to any random dictatorship, which would have the same measurements, but can also be the possibility that it has broken that trusted execution environment, and in that case, all the guarantees will be gone. So next slide, please. So what we concluded from the analysis is that using the proposed protocol, that is namely the one that I just described, a remote attestation only, section 6.1, the security breaks if there is even one compromised machine in the world, and that's really the focus, in the world, because it's trivial that if I break one machine's attestation key, of course, all the guarantees for that machine are gone. That's already known in the literature and in the research papers. But what is not known is that if what we are saying is a very strong statement, rather than just one specific machine, what it's saying is that you break one compromise, you have one compromised machine, and that's not the one that you wanted to communicate with, as was shown on the last slide. It could be anywhere in the world because you're not checking the identity at all. It may not even be in that specific data center that you wanted to connect to. And the condition for that is that its corresponding certificate has not yet been added to the revocation list. So until that is done, that is the vulnerability window, and that is typically large. We have seen for, let's say, attacks like SGX and so on. So that have been, it's not a very quick thing that, okay, so first you have to know that an attack happened, then you have to add it to the revocation list, and then all the process. So revocation is not easy. Next slide, please. So the solution that we propose is simply to combine the two chains. As I talked about it, the two are really complementary. So PKI cert gives you identity, and the evidence gives you the integrity of the computing environment. We really need to have both, such that we can have stronger guarantee rather than having one or the other. And the challenge here from the TLS protocol perspective was that the certificate message of TLS is not extensible. And for making that extensible, we had some proposals in the TLS working group. So I will not talk about the intra ones, as I said. So I will only focus on the ones which are post-handshake. So next slide, please. Okay, so there are some inherent limitations also of intra-handshake as we deep dive into it. So what we found was that compared to other solutions, it has its inherent complexity, and it goes as deep as the key schedule. So for making a new exporter, which needs designing a new exporter with the changes in the key schedule, first of all, and secondly, section 4 of the internet drafts, editors are claiming freshness by this approach because they have a nonce going from the TLS client hello message, and that is used for creating that evidence and then sent over as part of the certificate message. But in reality, there are two limitations that are not really discussed in the draft. Number one, that is, it's only at the time of the handshake when the handshake was established and not afterwards. So I have a diagram at the bottom which is showing exactly this thing. And this is a recent idea that Hank came up with, that why are we actually focusing on this replay attacks only from different sessions, and why not? So we can have different rounds of remote attestation session within one specific session which is going on, that is an attested TLS session, let's say. So we could have a round at the beginning, and then at some point in time, you might need another round to get a fresher or a newer status. But this protocol actually does not provide you with that facility, which means that you have guarantee of freshness only at the time at which the handshake was done and not afterwards. All that window is still vulnerable to any changes. And why that is important? That is important because of the second point, which is written beneath that, which is it's only for the claims available at the time of handshake and not afterwards. Similar to this, so the first one was temporally. It's more like what claims are available, the availability of the claims. and some of the claims might not even be available at the load time when the session or the session establishment time or the handshake time, let's say. And the point there is that, or what we really want to have some opinion on or discussion on is that what or how many runtime measurements are typically available at the time of the handshake. So I think that's the key point in deciding whether to go for intra or post handshake in the typical kind of use cases in confidential computing. And that's something that we need some feedback on. If someone has any opinion or maybe some ideas around this, we will really appreciate that, because I believe this is one of the key points that we need to resolve. Runtime measurements, I commented a couple of times in a review for the interaction model drafts, but it was not incorporated. So yeah, Thomas, please.
Just noting that intra and post are not mutually exclusive, so you can run intra first and then run as many posts you want if you want to check evidence at subsequent point in time.
But how? So how can you do it within? So
what do you mean by how? You
So
just
how
run you run separate sessions.
You mean that you start a new session, new handshake for intra? You are saying that you need a newer status. You start a new
Handshake,
right?
Yeah. So if you want to check that the state is still good, then you run a post, and then if it's good, then you keep going on with the intra that you have already established.
I'm a bit confused by that statement. So when you are saying that, okay, so you have, let's say, established one connection, right? So one session attested TLS by intra handshake protocol. So how would you do now post within that session? So
what's the problem?
So the problem is that, so are you proposing that within that session you send over a new exporter message for that? So the post handshake messages for that, is it so the 9261? So you kind of make it hybrid. Is it what you are saying?
Yeah.
Okay, right. Okay, thank you. June.
We're not getting audio from you, June, if you're speaking.
Okay, I think. Okay, so maybe you can write in the chat. I don't hear you.
Yeah, June, please write your question in the chat.
Okay, so I will proceed and come back to his question later on. So what we do here is basically this post handshake solution, which is one of the proposals that's based on RFC 9261. And what it does is basically that you do the standard handshake using the long-term key, and long-term key here is typically defined in TLS, namely the one which is CS certified. And then you do a round of post handshake authentication, basically using RFC 9261, which is you send an authenticator request, which contains the client certificate request, which is similar to the TLS message, which is the certificate request, which is from the server to the client. So this is the other way around. And then authenticator message will then, and this message will contain the nonce based on which the server will generate that evidence. And then it will be sent over as part of the authenticator and more specifically within the part of the certificate message. So it provides then the proof of possession of both the long-term key as well as the ephemeral key in the certificate verify message. And that would fix the problem that you have both chains and you provide the proof of possession of both keys. Next, please.
Thomas is in the queue. I don't know if you want to take questions.
Okay, yes, please.
Oh, sorry, I forgot to unqueue myself. Sorry.
Okay. So the open problems basically apply to both proposals, not only the intra. So that's basically next, please. I will describe first quickly the flow for the original path. What happens here And on the left, you see the TLS client from TLS perspective and the verifying relying party from attestation perspective. Okay, Deb?
Can you go back because you said an ephemeral key in the certificate verify message?
Yes, please.
Ephemeral keys don't normally have certificates? I think you're back 2 slides.
What slide do you want me to be on?
Slide
2
11.
slides back from where you are, 11 maybe. Or something. No, 1
12.
forward from that.
Yeah, this one.
Yeah, that one. So what's this discussion about certificate verify and ephemeral keys?
So basically the discussion is that we have 2 keys in confidential computing. One is the long-term key. So that basically relates to the discussion of the very first slide, which was saying that we have 1 key from TLS, we have 1 key from remote attestation, and unless we provide the proof of possession, it could result in a relay attack. I mean, the certificate message, if I provide, yeah.
Which of those keys have certs associated with them?
Both of them have the certs associated with them. So certificate for remote attestation is in the form of an evidence, not an X509. So it's in the CMW format. And the standard TLS has the CSINed certificate, which is on the top.
So
So
who assesses that certificate? I mean, who creates that certificate for the ephemeral key?
who creates that? The hardware creates that. So it relates to the very first slide that was there, which is that the hardware is, so the CA is generating the evidence that you are the owner of this server, right? So this is, let's say, cloud.example.com. And
that's a long-term key.
Hardware is generating the evidence for the software stack which is running on that server. So it's the evidence.
So the assertion is self-asserted.
Right, that's correct.
For the ephemeral key.
Right, but it's signed by an attestation key, which is within the hardware protected by the trusted execution environment.
Okay, so from a certificate verify point of view, from a TLS point of view, it's not really what normally is expected with certificate verify from TLS.
Right. So the standard TLS is just the first row that I have on the top. So the first arrow on the top, that's the standard handshake. So that certificate verify will contain the proof of possession of the PRIV LTK as it's written. But the certificate verify that is at the bottom, that will be basically the key, which is for the that is the ephemeral key, which is associated with the evidence.
So you're mixing and matching TLS terminology with whatever you're using for confidential computing terminology. It's confusing when you do that, by the way.
So it's in confidential computing, we have always this case, so that the ephemeral key means that it is generated within the TEE and it never leaks out from the, so it's a very common terminology, and we have within the authors, the editors, we have agreed upon this terminology for quite some time, like more than 6 months. So
I think certificate verify in TLS has probably been there for upwards of 10 or 15 years, right? Ever since they developed the ability to do mutual TLS. Or longer, because you do a certificate verify with the server key as well, right? So 6 months is not very long in TLS language.
Right. I mean, we are leveraging TLS. We are for our purposes. We are not saying, we are not changing the TLS terminology. TLS terminology, I mean, I don't fully understand the question. So,
No, you're reusing TLS terminology in a different way.
Yeah.
So you're overloading the term in a confusing way.
So what would be your proposal? Like, I have 2 certificate verify. I have to somehow differentiate them in some way. If I mean, the 2 chains.
So it's you're creating basically what I would call a self-signed cert, right? And you're using that to claim that you hold the private key. And so you're doing a proof of possession. I don't know what you want to call it, but calling it a certificate verify in TLS terminology is incorrect.
Well, it's, I think that ship may have sailed because we use the same when we added the support for raw public keys, there we essentially had no certificate and still used the certificate verified to demonstrate possession of the private key for that raw public key.
Okay, but then you're talking an XF509 certificate that you've
Yeah, it's not an
created?
X509 certificate anymore there.
I don't know. I don't know what you want to call it.
Yeah.
But it's confusing to me. As a
Yeah, I
PKI
see the
person, what you're
confusion,
doing is very confusing.
Yeah.
Maybe not everybody is up to speed on how certificate verify has been overloaded in the past, and then there are new proposals for other types of payloads like JOTS or COTS or something. Any of those, of which any of those could contain evidence. So it's just not clear. It would be helpful to just explain how the evidence is being tunneled through TLS handshakes currently, and how TLS could be modified in the future to make it more explicit that, hey, we're passing evidence here.
Right. Okay, so we will take this feedback into account for the next version. So next slide, please. Okay, so the next one. So I was discussing this one, which is the original path, how it should happen, and the related issues that we have. So on the left, you see the client. And from attestation perspective, the verifying aligned party. On the right, there is the attester from RAT's perspective and the server from TLS perspective. And what happens is the step one is showing that they want to establish a connection. Step two is showing that quoting agent is the attesting environment from RAT's perspective, which generates an evidence with these measurements and then sends over the evidence back to the target environment and the VM1, which is shown there. And in step four, it will convey it back to the TLS client, and which will then appraise it and accept it evidence because that's the measurement it wanted, and it was signed by the attestation key priv AK1 for the public key pub AK1, which is in its trust store. Next slide, please. So the problem that can happen is this one, which is namely the diversion attack within the CSP. So the first attack that I described last in the previous one was basically outside the CSP. So we wanted to connect to cloud.example.com. We were rerouted to a completely different one. And now this is within the CSP, which is according to the CC threat model, confidential computing threat model, that the CSP is untrusted. And what we are saying here, or what we are assuming here, is that let's assume a specific machine, not all of the machines, just one machine out of that CSP is broken. And broken here or compromised here means that the attestation key has been compromised. And then what it can do is it can generate an evidence which is shown on the step 2 with the same measurements as the client wanted, but with the public key which is associated with its own VM rather than the VM1. And because it has this attestation key, it's very, very easy for it to just sign anything that it wants. And then the step 4 shows that it conveys it back. And when the client will see it, it will appraise it and it will see, yes, this pub AK2 was also in its trust store, and it will accept it. So in this way, the VM2 is going to impersonate VM1, and the client never knows that it has happened. So that's one of the issues. Next slide, please. So trustee was mentioned already by Yogesh, and this is somehow also related to that, which is that the main problem is how do we provision the identity and the long-term key to the trusted execution environment, basically such that it can provide the proof of possession of both. That's the very first problem to solve, because only then you can have some solutions that we basically provide the proof of possession of both. These keys have to exist within the attester in order to do that, right? So typically the long-term key is with the host, which is here untrusted. And so how do you import that long-term key into the attester in the protected region, that is the VM, that is the box shown here below the point 1, consisting of the workload agent and the encrypted workload. And the thing is that this we have not formally analyzed, but we see a very typical pattern compared to the one that was shown on the last slide, or the last attack, diversion attack, which is only that the server and client roles have interchanged and the TLS protocol is whole symmetric. So we believe that this attack will still apply here. So it's what it is showing here is that the CSP will divert it to the broken machine, which is shown here on the right, the compromised one. And then the quoting agent will still generate the same measurements and M1 as the server desired. And but with the keys, that is the pub EK2 corresponding to the workload agent that it controls. And then the server is going to send it over the decryption key for the workload, and then it has the decryption key. It can then look into the data and the code as well, because that's already what it needs. So one question that we have here is basically who owns. So this was one of the proposals for KBS that came from Thomas. So and then we discussed that basically the same attack theoretically also applies here. Of course, as I said, we haven't formally verified it, but the thing that is blocking us is who owns the private part of the long-term key. So the proposal was that there is a certificate which is shown in the block of the encrypted workload, that it has the identity, the long-term key, which is the CA certified key, put into that workload from the beginning, and it's encrypted. Nobody can see that, but who owns that actually, that private key? Where is that private key? That's something which is blocking us from making some progress on this. And I would ask if someone has any opinion on this to unblock or to maybe suggest something so that we can move forward with this. Okay, if not, then we will proceed. So next slide, please. The kind of discussion we had in the CCC attestation SIG as well was a few things came up that, okay, so there are platform instance identifiers within remote attestation that we can use, or the owner identity fields. The thing is, they are typically set to null in all the cloud providers. And even if they are set to some specific value, operator, which is the adversary, can actually still provide the platform instance identifier of the compromised machine, which was shown on the right on the last slide. And secondly, there are security version numbers. And the idea was that, okay, so whenever that compromise happens, you can update that security version number and send over a patch, and then disallow all the previous SVNs. And the thing here is that this patch can only be applied when the vulnerability is known and even fixed, and the patch has been applied, and then you can apply such kind of this thing. So that vulnerability window still applies. Next, please.
By the way, we're approaching 20 minutes after, so.
Okay, so I think I will conclude after this slide. So the question here now is can the CSPB really be out of the TCB, which is the very conventional CCC threat model. And what I'm showing here, I will skip the points. I will just talk about the table. Actually, the first 3 points are basically for all the CSPs, and the last 3 are shown on the table, which is the VM firmware. Some of the cloud providers do not provide you the facility to basically have the VM firmware open source and to independently reproduce it. And secondly, the VTPM, which is doing the measurements, is basically outside the confidential VM in like AWS and Google. And the ability to fetch the raw evidence directly is also not provided by Microsoft. So each of the cloud provider has its own limitations, and there are trade-offs. So next, please. The open questions that we have in this are, we talked about remote attestation and specifically about attested TLS. What makes the what exactly is the boundary between those, and specifically about the post handshake, it's unclear that whether which place we put them in. Is it the channel binding, which is the distinguishing criteria, or something else? The second one is, can remote attestation be implemented on its own without any secure channel in CC context, confidential computing, and any concrete use case such as KBS or something, or even if this is it. And finally, the server's location from regulatory perspective, that some regulations might require, even if the data is encrypted, to remain within that specific location. So how do we satisfy that kind of requirement? Next, please. And the protocols that we have do not actually do that. And the next steps are to now thoroughly analyze the threat model, come up with a realistic one, I would say, while we believe that the one which the CCC has is not realistic, that is the CSP out of the TCB, is not a realistic one. And we are looking forward to do a thorough comparison of intra and post handshake in order to come up to some conclusion from security and privacy perspective specifically. Next, please. Okay, so next, these are some of the references, and I think that's it.
So we'll just transition to open mic, and you said you had a couple of questions you wanted to bring up.
Sorry, Ned, are you asking me?
Are you? Yeah, it sounded like you're done, but you said you had some open mic topics.
Yeah.
Do we want to transition to open mic?
One quick question.
Just to clarify, since there's only 10 minutes, there is a larger discussion that's been happening in the chat in terms of a request for another interim. So just in case somebody's not on the chat, we will need to hold an interim for all the discussion points to be wrapped up that were listed for open mic.
Okay, so plan on another virtual interim.
Yes, yes. So you and I can plan that and use the chat information for the agenda.
We still have 8 minutes-ish to deal with either activity on the chat, or Osama still had 3 more slides. Maybe you can.
Why don't we finish Osama's slides so that a topic gets completed?
Okay.
Right. I think that's just acknowledging everyone. Lawrence is always on top of my list. So in December, so he was very helpful in when we were really blocked, and all the other people listed here have been very helpful. Thanks a lot. Yeah, I think that I will skip the backup slides. So the question that I specifically want to talk about in general is about the draft on interaction models, that whether it's going to cover runtime measurements or not. So otherwise, we would like to have some some other things. And in Ireland, I believe it was in my presentation, it was discussed that that draft is the right place for the security properties. I don't see them yet, so I would like some clarity on it. So if that's not going to cover it, we might have a different draft which will cover the security properties of remote attestation.
Hank is in the queue.
Yeah, hi. So runtime integrity measurements are both a research topic and also sometimes just remote attestation done over and over again. So for the simple loop thing, I want to say, so you're doing like a post handshake remote attestation procedure to here, and then after some interval you do it again. So it's a frequency, yeah, and so that is a way to give insight into runtime integrity. There can be subscriptions into the TCB, the trusted computing base, that triggers as soon as something changes on the attester that reduces the time window of stale evidence. Of course, that's all implementation specific a little bit. So in general, the interaction model allows for this kind of looping. Of course, we do not, so the subscription, unsolicited push scenarios with the timestamps, we highlight that. We do not highlight that in the ad hoc, the challenge response remote attestation, because, well, that's up to you, right? So just do it once and then later do it again. We didn't feel the need to highlight, yeah, you can do this more than once. If such a simple addition would solve the runtime integrity question on the Chara, also that's easy. If there's more to it, maybe we can work together on creating a few phrasing text or maybe English structure changes that would help address your problem.
Right. So from my perspective, I'm mostly interested in the confidential computing thing. So I would like to see, for instance, like all VM-based trusted execution environments have these runtime measurement registers, and to kind of explore that, what would be the kind of the change. So the as was on one of my slides, so that's basically the whole thing that I'm mostly interested in. Doing it via post handshake will solve the problem. You can have these measurements at any point in time, but I want to really see from the intra-handshake perspective, if we don't have the hybrid combination that Thomas was mentioning, if we only have intra-handshake, how would it be comparing with that? So what kind of runtime measurements, what are the typical kind of use cases that, what runtimes are included in, what runtime measurements are included in these kind of use cases? And what kind of security problems which arise the protocol that we design from protocol design perspective? That's something that would be most interesting for me.
Yeah, so we want to give a good basis for protocol design. So if there's something missing here, I think we can check this offline first. But I'm not entirely sure how many protocol prescriptions or options should be put into this IDE, because then becomes a box of snakes at some point, and we might be overdoing it. So maybe we have that. Maybe there's a middle ground. So we can grow a little bit towards your requirement, and then you pick it up on the protocol side. That seems feasible. I'm not entirely sure about the any other mechanism than post, because post obviously inside the session you can do it over and over again, and as you just said, that is the easiest one. It's a very TLS specific problem to do this in the other ways. A pre could even be out of band, right? So then you absolutely detach from the TLS problem, maybe creating a recursive TLS problem, I don't know. And yeah, but we have to talk this offline, I think.
Okay, sure. Thanks.
Okay.
Thank you.
Thank you. So we have like 3 minutes of open mic time.
Hi. Yeah, I just wanted to clarify, which I forgot to add in the presentation, is there was an earlier draft which talked, the name looks similar on multi-verifiers, which was presented by June in, I think, IETF 120 or somewhere, but that was addressing a slightly different problem domain. So please do not get confused. This is a new draft with a different set of problems. So just to clear the confusion, that draft is archived. The old draft from IETF 120 is archived, and this is the draft we are pursuing, which I shared in the chat. So that's a clarification. Thank you.
Thomas?
Just a quick question about the discovery using MAD files that was brought up at the in Bangkok. There has been some mailing list discussion, but I wanted to ask the chair what their thinking is at this point. There was more than one people, expressing support for that, and but the discussion didn't seem to conclude. So
there was a request to move it to a different working group, so we're sorting through that.
Okay, I didn't notice that. Was it on the list?
I don't think so.
That's why. Okay, then
yep.
I'll shut up. Thanks.
Okay. Anything else? We have 1 minute. All right. Thanks, folks. That's a wrap for today.
Thank you all for the participation.
Thank you for notes takers. We'll follow up with posting the notes as minutes.
Thank you. And we'll also follow up with an interim. So I think if there's explicit topics or you're presenting, if you could send a message to the list or to Ned and I, maybe the list is best so that we can refine the agenda to reach everybody's questions. Thank you.
Okay. Thanks, everybody.